Hey everybody, so this is the solution video to Worksheet 1.7. We'll be talking about graph transformations. And for number one, we are given a graph with specified points, and we're asked to perform various transformations given the notation for f of x for this particular function that's given for each of these parts. So let's go ahead and start with part A. So the first thing I might suggest is to try and decipher this notation to determine what type of transformation you're looking at performing here. So here we've got our function f of x, which is essentially just our y value of our function. And this is saying we're going to take our function, any random y value, and add 1 to it. So this is telling us that the transformation that will be involved here is a shift up of 1 unit. So the transformation is a shift up of 1 unit. So now we've identified the transformation. Let's think about how this transformation will affect each of these coordinate points. And we consider that if we're shifting up, the only thing that we're changing is the y value. And in fact, we're adding 1 to each y value. So for each y coordinate, what we're going to do, this implies that we're going to take whatever the pre-existing y-coordinate was and then just add 1 to it. So, for example, if we were to go, and by the way, the x's remain unchanged in this case because this is the only transformation occurring. So the x's are unchanged. So we might as well put that x-coordinate is unchanged. So let's go see how this transformation affects each of the points, and then we'll put a graph together. So let's list the points that we were given. So we've got the point 0, 1, we've got the point 2, 3, we've got the point 4, 2, and then we've got the point 5, 0. And we just got that from the graph that was given to us. So we transform each of these points, given that what we're doing is a vertical shift of 1 up. So the point 0, 1 will be transformed to 0, x is unchanged, and the y we add 1 to, so that'll give us 0, 2. For the next point, the x is unchanged, we add 1 to the y coordinate. X is unchanged, we add 1 to the y coordinate. X is unchanged, we add 1 to the y coordinate. So we've transformed these points, and now we should be able to get a fairly decent sketch going on here. So we'll go ahead and we'll draw our axes here. We look at the range and the domain of this. We're going from 0 to 5 for the domain, and the range is going to stay between 1 and 4, so we can label our axes accordingly. So 1, 2, 3, 4, 5, and then we've got 1, 2, 3, and we really need to take it up to 4. So let's go ahead and plot these new points that we've got. So 0, 2 will go right there. 2, 4 will go up here. 4, 3 will go right here. And then the point 5, 1 will go right here. And then we can connect these points as was suggested in the graph that we've given. So the graph we end up with here is our function y is equal to f of x plus 1. And we clearly see that this is the same graph, just sort of shifted up 1 unit. Okay, so let's take a look at the next one here. So we've got f of x plus 1 with the plus 1 inside of the function notation, so slightly different. So again, let's think about what this transformation is going to be. So adding 1 to the x within the function as the argument, this is going to result in a shift to the left 1 unit. So because it's added to x, it's actually going to shift it to the left, a little bit counterintuitive to what we might think. But anyway, so that's what we're going to get. And if we think about how this is going to transform each of the individual points, sort of in the same way that the last problem did, what we're going to see is that this is going to affect the x coordinate. By shifting side to side, the x coordinates are going to be affected. So for each x coordinate, where essentially if we wanted to move every point to the left, we're going to take the pre-existing x-coordinate and then subtract 1 from it. So that's how we can actually transform the individual points. The y-coordinate will be unchanged. So let's go ahead and do the same thing that we did last time. We'll go ahead and name the points that were originally given. So 0, 1, 2, 3, 4, 2, and 5, 0. And then we will apply this transformation. So we're going to take each x-coordinate and subtract 1 from it. If we subtract 1 from 0, we'll get negative 1, 1. If we subtract 1 from 2, we get 1, 3. Subtract 1 from 4, we'll get 3, 2. And then we subtract 1 from the 5, that's going to give us the point 4, 0. So these are the 4 transformed points which will affect a shift to the left of 1 unit. And if we then graph these points on a set of axes, we're going to need to get a little bit farther over to the negative side of the x-axis. We'll leave some space there. So we'll have negative 1, 0, 1, 2, 3, and 4. And then we'll go up to 4. So we've got 1, 2, 3, 4 on the y-axis, and then we'll just go ahead and we'll plot these points. So negative 1, 1, we'll put that right there. 1, 3, we'll put that right there. 3, 2 gives us a point right there. And then 4, 0 gives us a point right there. So we connect these. Kind of missed that. Easier said than done. Okay, so that's our graph, and if we look at the curve, the last one, we can see that has been shifted to the left 1 unit. So this would be a graph of y is equal to f of x plus 1 as argument. Okay, so let's check out the next two. We'll bring back a copy of the graph here. So for this next one, part C, we've got a constant multiple in front of the entire function, f of x. And again, that's kind of just like our y-coordinate. Y is equal to f of x. So we're, in essence, multiplying each y-coordinate by 2, which is going to stretch this vertically. So we would describe this as a vertical scaling by a factor of 2. In this case, this is going to result in the vertical stretch. Okay, so the x-coordinate really is unaffected by this. The only thing that is going to be affected is the value of the y-coordinate. And to get this, we will say that for each y, what we're going to do is we're going to take the y that we start with and then multiply it by a factor of 2, and that will give us our stretch. So we write down the points. We've got 0, 1, we've got 2, 3, 4, 2, and 5, 0. And if we take each of the y-coordinates and multiply them by a factor of 2, that's going to give us 0, 2, 2, 6, 4, 4, and multiplying 0 by a factor of 2 will give us 0. So notice that that point on the x-axis is actually unaffected by the vertical stretch. But the farther away we get from the x-axis, the more drastic that the stretch seems to be. That's the nature of the scaling. So if we were to graph this, we've got our x-axis and our y-axis. We've got the points 1, 2, 3, 4, and 5. And then we will go ahead and we're going to need to go up to at least 6 here. So 1, 2, 5, and 6. And let's just drop these points on there and connect the dots. So we've got 0, 2. We've got 2 all the way up here to 6. We've got 4, 4. right about here, and then 5, 0 stays planted on the x-axis. And then we just connect this all up. Probably do that a little better. Okay, so there's our curve, and we can see it's still sort of planted in the same spot, just skewed up slightly vertically. So this would be the graph of y is equal to 2 times our function f of x. And then for our last one here, we've got y is equal to minus f of x. By taking the function and multiplying the entire thing by negative, which is what we're being asked to do here, this is going to change the sign of every single y-coordinate, and that's going to affect an x-axis reflection. So any positive y-coordinates will become negative, any negative y-coordinates will become positive, and we'll get that reflection going on. And if we wanted to actually change our curve, what we're going to do is we're going to take each y. So for each y, we're going to make it negative, or multiply it by negative rather. So we're going to change the sign of each. So let's go ahead and do that with each of these points. So we've got 0, 1, 2, 3, 4, 2, and 5, 0. And if we change the sign of all of the y-coordinates, x's are going to be unchanged here because we're just doing one transformation. It's going to be 0, negative 1, 2, negative 3, 4, negative 2, and 5, 0. So again, the x-axis really doesn't get changed for this vertical transformation. And when we put our sketch together, our range has dropped to the negative side of the y-axis, so we can kind of change that a little bit. So here's our y and here's our x, and we've got 1, 2, 3, 4, and 5, and then we're going to go down to minus 1, minus 2, minus 3. I'll put a minus 4 in there for good measure. And we'll plot these points. So we've got x equals 0, y equals negative 1, x equals 2, y equals negative 3, 4, negative 2, and then 5, 0. And we get this as our curve. And this is exactly what we'd expect to have seen for a graph of y is equal to minus f of x, considering this is an x-axis reflection, because we can see compared to the original one, this is the same curve, just sort of flopped over the x-axis. Okay, so next we're going to try a problem where we're actually coming up with a formula given particular prescribed transformations that we're asked to do. So for all of these, we're going to start with a baseline function of f of x is equal to the square root function, square root of x. And we're going to find the formula for a new function that reflects each of these transformations in a, b, and c. So let's start with part A. So we need to do two things here. So the first thing we've got to do is we have to take our function and do a shift to the right. Now what I like to do is use the function notation to first sort of represent each of these transformations. So to take any given function and shift it to the right 2 units, it would look like this. Whatever your function is, f of x, and we're going to the right 2 units, so f of x minus 2. And in the case of our function, we know that f is the square root of x, so it would make our function look like the square root of x minus 2. Just like we were evaluating functions. We take f of x, we evaluated x minus 2, which gives us the square root of x minus 2. Then we look at our second transformation. So we're also going to shift this down 2 units. So if we're accumulating each of these transformations, we know that we've already got f of x minus 2 for our shift to the right 2 units. Now we want to shift it down 3, so we're going to take that function, and on the outside we're going to subtract 3. And again, if we put this along with our square root function, this would be, we take f, we evaluate it at x minus 2, and then we subtract 3 from it. So that minus 3 is on the outside of the square root function. And now we're done. So we've done all of the transformations. So in the end, this new function g of x is actually going to be the square root of x minus 2 minus 3. So that would be our transformed function. And the nice thing about these is if you ever want to, you can kind of graph the two on your calculator, and you can actually see the transformations occur between the square root of x versus this transformed function. Okay, so for part B, let's do the same type of thing. First, we'll identify each of these transformations. So reflecting across the x-axis means that we're going to take our function f of x and make it negative, change the sign. So in this case, with the square root function, we're going to take the square root of x and put a negative out in front. If there's anything else going on in here, we'd need to put in parentheses, put the negative on the outside, but it's pretty simple right now, so we can just sort of stick with that. For the second one, we've got our reflected function, and now we want to shift it up 1 unit. So we're going to just add 1 on the outside there. So now what we've got is we've got minus the square root of x plus 1. And that's it. So our new function, g of x, is going to be minus the square root of x plus 1. And for this last one, we've got 3 different transformations that we're going to need to accumulate here. So the first one is a shift to the left 1 unit. So we take whatever our function is, and we evaluate it at x plus 1 to affect the left shift of 1. In this particular case, that means that we're going to have the square root of x plus 1 all under the square root. Second, we want to stretch this vertically by a factor of 2. We know that this means that we take whatever our function is and we just multiply it by that factor. In this case, it's 2. So this is going to leave us with 2 times the square root of x plus 1. And then lastly, we want to shift this function's already gone through a few steps. We're going to shift it up 2 units. So we've already transformed, and we're going to shift it up 2 units by adding 2 to the outside of that. And then we'll get 2 times the square root of x plus 1, and then on the outside we'll have the plus 2. And a lot of times order really matters here, so you want to make sure that you take it step by step by step and not get ahead of yourself with problems like these. Okay, so that should do it for graph transformations, and I will see you all in the next video.